An unexpected revelation from the James Webb Space Telescope. The James Webb Space Telescope has astounded the scientific community with its ability to identify urban light signals originating from space. Situated a staggering 7 billion kilometers away from Earth, this discovery has opened new possibilities in the search for extraterrestrial life. By concentrating on Proxima Centauri b, the closest exoplanet to Earth, the telescope uncovered unusual bright lights. What might be radiating from its surface? Could these mysterious lights on Proxima Centauri b signal the existence of life beyond our own? For years, humanity has yearned and searched for signs of life in the vast expanse of space. Any indication suggesting such a possibility has been met with great excitement. Recently, the scientific community was stunned when the James Webb Space Telescope presented compelling evidence of possible life forms in the cosmos. While exploring the universe and transmitting vital data back to Earth, the telescope detected strange urban-like lights coming from Proxima Centauri b, an exoplanet that orbits a distant star system. These lights, as their name suggests, are the first of their kind ever to be seen in space, appearing to illuminate what seems to be a far-off city. The concept of an alien civilization existing in this system has left scientists puzzled, filling them with a sense of awe and wonder. Each researcher is amazed by the possibility that this discovery could be what they had long hoped for. If confirmed, this would mean that intelligent organisms have developed societies far beyond our understanding, right here in space, and we are only beginning to learn about them. As scientists analyze the lights from a distance of 7 billion kilometers, NASA engineers wonder how long these lights may have been glowing in space, waiting for humankind to develop the necessary technology to detect them. David Kipping, an astronomer from Columbia University, describes Proxima Centauri b, the exoplanet where these city lights have been detected, as a celestial body with unusual heat patterns that differ from those seen on other planets. While typical rocky planets absorb sunlight and release infrared radiation, Proxima Centauri b displays markedly different behavior when interacting with its star, Proxima Centauri. This distinct behavior has made it an ideal subject for the James Webb Space Telescope, whose advanced infrared capabilities are highly sensitive. The thermal signature of Proxima Centauri b will be key in uncovering the secrets of its atmosphere. Taking advantage of the telescope's state-of-the-art infrared imaging, scientists plan to study the planet's atmospheric mysteries and determine whether it might be able to sustain life. The James Webb Space Telescope, with its exceptional infrared sensitivity, is ideally suited for probing Proxima Centauri b, as it can detect even the faintest light signals in the cosmic darkness. Its narrow frequency band, 1,000 times narrower than starlight, allows it to detect artificial illumination, making it an invaluable tool in the search for extraterrestrial life. Proxima Centauri b's intriguing connection between its surface features and interactions with its host star further enriches its appeal. The daytime side of the planet is believed to be covered with solar panels that capture energy from its star, while its night side experiences extremely cold temperatures. This contrast in temperatures, due to the planet's atmospheric composition, offers an intriguing area of study for astronomers. Furthermore, the telescope can effectively measure the planet's thermal emissions, providing critical data on its atmospheric properties. The JWST's orbit, synchronized with that of Proxima Centauri b, ensures thorough evaluations of both its daylight and nighttime cycles. These observations span 11.2 Earth days, giving scientists a unique opportunity to study the exoplanet's full rotation. The next major step will involve analyzing the atmospheric chemistry of Proxima Centauri b to determine whether it could support life. This will focus on gases such as oxygen, methane, and water vapor, which are considered essential indicators of habitability. If these gases are detected in the atmosphere, it could imply that the planet has conditions favorable to life. However, this task is exceptionally challenging, as it requires capturing and analyzing the light passing through the planet's atmosphere. Although the James Webb Space Telescope is highly capable of studying the atmospheres of other planets, it faces limitations, particularly in detecting oxygen, a vital indicator of life. Nevertheless, the telescope will still search for other elements like ozone, which could offer further clues about the planet's potential for habitability. It is important to note that the JWST cannot investigate every possible world with habitable conditions, as its capabilities are restricted to focusing solely on the nearest exoplanets. For a more in-depth investigation, astronomers are relying on ground-based observatories such as the Extremely Large Telescope, ELT, which is expected to begin operations in 2028. This facility will enable even deeper exploration of distant exoplanets. Scientists eagerly anticipate the launch of future space telescopes, which will expand our knowledge of exoplanet exploration. While the JWST has its limitations, it remains a crucial tool for deciphering the mysteries of faraway planets. Future missions will focus on overcoming obstacles, such as reducing the glare of host stars, to better study the light reflections from exoplanets themselves. This process will help researchers differentiate between gases produced by life forms and those generated by geological processes. Despite these challenges, scientific progress continues, and the James Webb Space Telescope is a pivotal step forward in our understanding of distant worlds and the broader universe. After decades of research and exhaustive searches for life across the cosmos, the question still lingers: are we truly alone in the universe? The search for life beyond Earth is one of the most profound endeavors in modern science. With each new discovery, whether large or small, the mystery deepens, and yet, the excitement grows. Proxima Centauri B's enigmatic lights, captured by the James Webb Space Telescope, have added a thrilling new layer to this ongoing investigation. If scientists determine that these lights are indeed artificial, it could change our understanding of life in the universe forever. The implications of such a discovery are monumental, suggesting that life, and potentially even intelligent civilizations, may be significantly more common than previously believed. The possibility that a technologically advanced civilization could exist millions of light-years away challenges everything we know about space, time, and the development of life. While it is still early days in the investigation, the urban light signals observed on Proxima Centauri b are an extraordinary hint that we might not be alone. The proximity of Proxima Centauri b, located just over 4 light-years away from Earth, makes it a prime candidate for further study. The telescope's capacity to detect minute signs of artificial light so far from home showcases the progress we have made in space observations and technology. As scientists continue to investigate the James Webb data, they will not only focus on the urban lights but also on other key atmospheric indicators that could point to the presence of life. As humanity stands on the precipice of discovery, the search for life beyond Earth has never been more compelling. The James Webb Space Telescope has already provided unprecedented insights, yet its observations are just the beginning. With every exoplanet analyzed, scientists refine their understanding of what conditions may allow life to flourish. Proxima Centauri b is an enticing candidate, but it is only one among thousands of known exoplanets. What if there are other planets, perhaps even more hospitable, hidden within the depths of the cosmos? The next generation of telescopes will push the boundaries of our knowledge even further. The Extremely Large Telescope, ELT, set to become operational in the coming years, will offer even greater precision in studying planetary atmospheres. Other planned missions, such as the Habitable Worlds Observatory and the Nancy Grace Roman Space Telescope, aim to detect biosignatures, chemical indicators that could suggest the presence of living organisms. Additionally, breakthrough technologies in space travel could bring us closer to direct exploration of exoplanets. Concepts such as light sail propulsion, which could accelerate small probes to a fraction of the speed of light, might one day allow humanity to send robotic explorers to nearby star systems like Proxima Centauri. If successful, such missions could return data within our lifetimes, offering a definitive answer to the question of extraterrestrial life. Meanwhile, advancements in artificial intelligence and machine learning are transforming how astronomers process vast amounts of space data. AI-driven models can now identify subtle patterns in telescope readings, helping scientists distinguish between natural planetary phenomena and potential signs of artificial structures or technology. Could it be that signals of extraterrestrial civilizations have already been detected, hidden within the noise of cosmic data? Despite all this progress, the search for life remains a delicate and complex endeavor. The discovery of extraterrestrial life, whether microbial or intelligent, would fundamentally alter our understanding of our place in the universe. But even if we do not find life soon, the journey itself is invaluable. Each new piece of knowledge deepens our appreciation for the vastness and intricacy of the cosmos. As the James Webb Space Telescope continues its mission, and as new observatories prepare to join the search, one truth becomes increasingly clear: the universe is filled with mysteries waiting to be unraveled. Whether we are on the verge of confirming alien life or merely scratching the surface of what is possible, the quest for understanding will continue to drive us forward. For now, humanity watches, listens, and wonders, gazing at the stars, waiting for the moment when the universe finally answers back. Proxima Centauri b and other potentially habitable worlds. While the James Webb Space Telescope is already making history with its discoveries, its journey has only just begun. The telescope's incredible capabilities will allow for continued exploration of distant worlds, providing a deeper understanding of how planets shape, change, and possibly develop the conditions essential for life. With each new discovery, we move closer to answering questions that have fascinated humans for centuries. In addition to observing the light coming from Proxima Centauri b, future missions will focus on gathering even more data about the planet's atmospheric composition. Scientists are particularly interested in detecting key gases such as oxygen, methane, and carbon dioxide, which are often associated with biological processes. If detected, these gases could serve as biomarkers, indicating that life may indeed exist on this distant exoplanet. However, detecting these gases is no simple task. The challenge lies in isolating their faint signatures from the overwhelming light of their host star. The next generation of space telescopes will likely be able to address this challenge, enabling more accurate measurements of the chemical makeup of distant planetary atmospheres. This progress will be crucial in determining whether Proxima Centauri b has the right conditions for life to thrive. As astronomers and researchers continue to explore these possibilities, they are also aware of the limitations of current technology. The James Webb Space Telescope is revolutionary, but it cannot explore every exoplanet. Its observational capacity is limited to certain kinds of planets and stars. To broaden our understanding, ground-based observatories will play a critical role in complementing the telescope's work, offering new ways to analyze distant worlds in greater depth. The future of space exploration. The future of space exploration is incredibly exciting. With advanced instruments like JWST, the ELT, Extremely Large Telescope, and other upcoming technologies, we stand on the brink of answering some of humanity's most profound questions. Could there be other worlds with civilizations waiting to be discovered? Or are we, in fact, the only sentient beings in the vast universe? Only time and continued research will tell. As we venture deeper into space, each breakthrough brings us one step closer to understanding the full scope of the universe and our place within it. The recent findings from the James Webb Space Telescope offer hope that we may not be as isolated as once thought. The discovery of urban-like lights on Proxima Centauri b provides a tantalizing glimpse into the possibility that intelligent life might exist beyond Earth, challenging the long-held notion that we are alone in the cosmos. The excitement surrounding these urban light signals stems not just from their unusual nature but also from the profound implications of such a discovery. The idea that a distant world could host an advanced civilization raises fundamental questions. Might we one day interact with an advanced alien society that has thrived in ways similar to humanity? Could these lights truly originate from an intelligent source, signaling the dawn of a new era in cosmic exploration? The challenge of detecting alien signals. At this point, the evidence remains preliminary, and scientists are cautious in their interpretations. Yet, the mere fact that these lights are being detected from such a faraway exoplanet is a breakthrough in itself. It signals that our technology is advancing to the point where we can detect even the faintest of signals from alien worlds. JWST's ability to capture such faint light emissions and investigate their origins is a testament to the progress we've made in space exploration. Looking ahead, scientists will continue to monitor Proxima Centauri b using every tool at their disposal to gather more data about the planet. One of the most critical next steps will be to conduct detailed studies of its atmosphere, focusing on the composition of gases such as oxygen, carbon dioxide, and methane. Since these gases are often associated with biological processes on Earth, their presence in an exoplanet's atmosphere could provide strong evidence of life. However, exoplanet atmospheric research is still in its early stages and remains a complex, highly technical challenge. The difficulty lies in isolating the dim light that passes through a planet's atmosphere from the overwhelming brightness of its host star. As astronomers refine their techniques and develop new instruments, they hope to detect even more subtle signs of life or habitability on distant worlds. The James Webb Space Telescope is well suited for this task, thanks to its advanced infrared capabilities. By focusing on the infrared spectrum, the telescope can detect heat emissions and light signals invisible to other telescopes, allowing for more precise study of exoplanetary environments. Limitations and future advances. Despite its power, JWST has its limitations. For example, detecting oxygen, a key indicator of life, remains challenging. Oxygen is a reactive gas that doesn't persist in an atmosphere without a constant replenishment source, typically from biological activity. While JWST can detect gases like carbon dioxide and water vapor, its ability to detect oxygen is restricted by its resolution and sensitivity. Nevertheless, the search for life will continue through multiple avenues. In addition to JWST, other observatories and future space missions will play a significant role. Ground-based telescopes, such as the Extremely Large Telescope, ELT, are expected to provide complementary data. The ELT, set to begin operations in the near future, will feature a much larger aperture and increased resolution, allowing astronomers to study distant exoplanets in unprecedented detail. With the combined efforts of ground-based and space-based observatories, scientists will be able to create a more comprehensive picture of the conditions on planets like Proxima Centauri b. Expanding the search for life. As technology advances, astronomers are eager to expand the search for life beyond Proxima Centauri b. Other exoplanets, such as those in the TRAPPIST-1 system, have also shown potential for habitability. These planets orbit a small, cool red dwarf star and are located within the habitable zone, where liquid water could exist. By studying multiple planetary systems, scientists hope to identify patterns that could indicate the presence of life elsewhere in the galaxy. Another critical aspect of this search involves understanding the role of planetary magnetic fields. On Earth, the magnetic field protects the atmosphere from being stripped away by solar winds, a crucial factor in maintaining habitable conditions. Researchers are investigating whether exoplanets like Proxima Centauri b possess similar protective fields. If they do, it would increase the likelihood of these planets sustaining life over long periods. Future missions and technological innovations. The next generation of space missions aims to push the boundaries of our knowledge even further. NASA, ESA, and other space agencies are already developing new observatories that will complement JWST's findings. Some of the most anticipated missions include the Habitable Worlds Observatory, HWO, designed to directly image exoplanets. HWO will be capable of detecting Earth-like planets around Sun-like stars and analyzing their atmospheres in detail. LUVOIR, Large Ultraviolet Optical Infrared Surveyor, a future space telescope concept that would provide even higher resolution images of distant worlds. The Nancy Grace Roman Space Telescope, expected to launch in the 2030s, this observatory will use advanced coronagraph technology to block out starlight, allowing for better observation of exoplanets. In addition to space-based missions, ground-based telescopes such as the 30-meter telescope, TMT, and the Giant Magellan Telescope, GMT, will offer unparalleled views of exoplanets and their atmospheres. These telescopes will work in tandem with JWST, providing additional data and refining our understanding of distant worlds. The implications of first contact. If we were to detect undeniable evidence of intelligent life, it would revolutionize our understanding of the universe and our place in it. Scientists and philosophers alike have debated the potential consequences of first contact, raising questions such as: how would humanity react to the confirmation of alien intelligence? What ethical considerations would come into play when interacting with an extraterrestrial civilization? Would such a discovery unite humanity, or create new divisions? While these questions remain speculative, the scientific pursuit of life beyond Earth continues to inspire curiosity and wonder. Whether we discover microbial life on an exoplanet or signs of an advanced civilization, the implications would be profound. Looking to the future. The search for life in the universe is one of the most ambitious scientific endeavors of our time. With each technological breakthrough, we move closer to answering the age-old question: are we alone? The James Webb Space Telescope has already provided remarkable insights, but it is only the beginning. As humanity continues to explore the cosmos, future discoveries may challenge our understanding of biology, evolution, and even the nature of intelligence itself. The coming decades promise to be a golden era of space exploration, with new missions, powerful telescopes, and perhaps, one day, definitive evidence that we are not alone in the universe.